This is geometry. We're working on our algebra review. We are factoring. We're doing factoring by grouping. This first set of examples would actually be after a step or two of factoring a quadratic. We factor a trinomial. After we get our two terms that are in the middle, we can use a factor by grouping method. And then further down the page, we will factor cubic equations. So when we use factor by grouping, we want to group our two terms together. There will always be four terms. We're going to circle these two together, and we're going to circle these two terms together. That just gets our eyes to focus in on what we're supposed to be looking at. So what can we factor out of this first set? What do they have in common? What can you divide by? X. They both have an x to the first power. This has x to the second power, but that's made by x times x. So we factor out our x. Now we think about what is going to be left inside the parentheses. If we factor an x out, so x times what makes x squared? Well, that's going to be x times x. X times what is going to make negative 3x? And that's going to be a negative 3. Then we bring down the sign that is in the middle of the two circles. So that's a plus. Then we look at our next two values. This is a 5. This is a 15. What can we divide into 5 and into 15? Of course, a 5. So 5 times what makes 5x? So 5 times x makes 5x. Positive 5 times a negative 3 makes a negative 15. Now, one thing that's really important to notice, look at your parentheses. Your parentheses are exactly the same. They have to be exactly the same. Because here is actually where we're doing some other factoring. We're going to factor out what these two groups have in common. They have an x minus 3 in common with each other. What else do you have? You have an x and a 5. So that would be a factored form of what we started with. When we come to our second one, same process. We circle both groups. You decide what you can factor out of the first group. You should make a choice. What can you factor out of that? Factor out an x. That's going to leave us an x and a 4 left inside because x times x gives us x squared, and x times 4 gives us 4x. Bring down your sign. You can factor out a 4. That leaves us an x and a 4 left over. Because 4 times what makes 4x? 4 times x. 4 times what makes 16? 4 times 4 makes 16. You bring down your x. You bring down your positive 4. And both groups have an x plus 4 in it. Now you can leave that as your answer. You could also, which might even be better, you could also write it as x plus 4 squared, because you have x plus 4 two different times.
Wait, can you just show number 1?
So number 3, you should have an idea of how we're going to start this. I encourage you to try to get ahead. at least with your mind. Okay, next he's going to factor out something that he has in common. I notice that a 2 divides into 2 and 4. And they both have an x. So that's going to leave me an x minus a 2 left inside. Bring down my sign. Factor out my 6. 6 times x, 6 minus 2. And I get 2x plus 6 and x minus 2. Now I don't get full credit for this. What's wrong with my answer? I haven't done anything wrong, but what's wrong with my answer if I don't get full credit for this? We can simplify out, we can factor out. We notice these are both even numbers, so we can divide both of those by 2 or factor out the 2. And that would leave me an x plus a 3 and x minus a 2. You don't lose what you factor out. You got to hold it out there. And our last example, in this set, we can factor out a 2x. That leaves me 2x plus 3. Bring down my sign. Factor out the 4. 2x negative 4 times a positive 3 gives me a negative 12. My parentheses are exactly the same. I bring down my 2x minus 4 and my 2x plus 3. I notice that the 2 and the 4 are both even numbers, so I can factor out another number. There we go. So now you have 4 examples that you try. Pause the video, work through your 4 questions, and then start the video back up and we'll work you through it. So as you see, we've worked through the practice problems. We've got x plus 7, x minus 4. We could factor out the x and factor out the 7. All right, just check out your answers, see how you did. All right, now we're going to move down to where factor by grouping is needed. This factor by grouping up here actually came from if we were working with x squared plus 3x minus 28, and we had to factor that apart. We would have to figure out what multiplies to be 28 and adds to be 3. We figure out that that's 7 and negative 4. We put those into our line, and we can use factor by grouping. We only focused on that portion of it. But here, we're working with cubic equations. Look at, not every term has an x in it. We're still going to do it exactly the same way. So you look inside your first set here, and what do you notice? They both have an x, but it's even better than they both have an x. They both have at least an x squared. This one has a square, this one has a cube. This has 2 different x's in it, this has 3 different x's in it. So the most I can bring out is x squared. And that leaves me with x minus 3. Bring down my plus. Factor out my 4. X minus 3. That leaves me with x squared plus 4 and x minus 3. We come over here to the second question. Circle both sets just like we did before. Factor out what you can, which is an x squared. Actually a 9. They both are divisible by 9. So 9x squared. That leaves me with a 2x minus a 1. You have to have the 1 to hold that place value. You have to be able to distribute it back in to get two different values. Bring down your negative. Factor out your 4. That's 2x minus 1, because a negative times a negative makes a positive. Bring down my 9x squared minus 4 and 2x minus 1. Now I look at this one and I don't get full credit for that. This is the difference of two squares. This is the assignment we did the other day. Can you take the square root of the first term? Can you take the square root of the second term? Yes and yes. So we have 3x minus 2 and 3x plus 2. And you also have your 2x minus 1. So in a cubic question, you might even have 3 parentheses. Because when you multiply that all together, you would end up having x times x times x, which is x cubed.
Wait, could you just do 3x minus 2? Or no, because never mind. Never mind. I answered my question.
All right, this next one's kind of weird. The numbers are so big, a little intimidating. But I believe 24 goes into both of these numbers. So 24x squared. And that would leave me 2x. And that would leave me a positive 3. Bring down my sign, which is a negative. I know the largest number that goes into 27 and into 36 is just 9. But when I distribute it back in, I'm left with a 3x and a positive 4. These parentheses are not the same. So we could call this prime. It might not be prime. It might actually be factorable in a different method. But it's not factorable by grouping, that's for sure, because the parentheses are not the same. We'll just say that it's prime because we can't break it into factors.
On the test, will there be prime?
That is a possibility. So here we have 4x squared. That leaves us with a 3x minus 4. Bring down your sign. Nothing factors out of 3 and 4, so I have to put at least a 1 there. And I would be left with 3x minus 4, because a negative 1 times a negative 4 gives me a positive 4. So I have 4x squared minus 1 and 3x minus 4. But I have to continue factoring this down into 2x minus 1, 2x plus 1, and we have our 3x minus 4. Because that first parenthesis was the difference of two squares. You can pause the video, work through the U-tries. All right, checking your answers. X squared plus 3, x minus 5. These are the u tries. This is the difference of two squares, so we can factor it apart again. This is the difference of two squares, so we can factor it apart again. This is not the difference of two squares. We cannot factor it again. And then for multiplying, if we're going to use FOIL, that means we multiply the front. When we multiply the outer, we have negative 12x squared. And the inner is going to be positive 12x. And the end gives us negative 9. There's no like terms in there. We cannot group those together. 4x squared y, 6x squared yz squared, 14yz if you write it in alphabetical order, and 21, there's two z's that are going to match, so the exponents give us 3 z's. So we have yz cubed. No like terms. Alright, let's leave this one alone, but FOIL this together. Well, actually, now since I look at the numbers, it might actually be better to multiply this. We get 3x squared. We're going to get a positive 6 and a negative 6. That's going to cross out. So then we have negative 4. 2x plus 1. Then we're going to have 6x cubed plus 3x squared minus 8x minus 4.